Okay, so guys, in last sessions, as we have not completed your DHCP and I have also needs to cover your ECMP. So let me first complete these two things. Okay, so what happens if I have mentioned here DHCP, client, server and relay? So what we can do, let's suppose this is my Palo Alto firewall and this is the interface of Palo Alto, let's say Ethernet 1/2. This interface part of your inside zone, right? Now whatever machines we are having here, if on these machine you want, they can get the IP address from DHCP. So what you can do, either you can put the DHCP server here. You need to put one DHCP server, right? You have to introduce one DHCP server in your inside network. Or the thing is, otherwise what you can do, you can configure the DHCP services in your Palo Alto firewall. So what? Now Palo Alto firewall basically issue the IP address to these particular machines. So these machines, they will get the IP address from this Palo Alto, means Palo Alto start acting as a DHCP server. So we can configure Palo Alto as a DHCP server. Let's suppose we are in one more interface which is Ethernet 1/3, and let's suppose on this interface we want, on my Palo Alto file, it can receive the IP address from DHCP, and you are having your DHCP server here. This is your external DHCP server, or we are having this DHCP server. So this, he can provide the IP address, subnet mask, default gateway, DNS settings to your machine. So what it will do, if you will enable the DHCP client option here, so what it will do, this Palo Alto machine, it can get the IP address from DHCP server, right? So we can use Palo Alto machine as a DHCP client. We can also enable the DHCP server option on the Palo Alto firewall. And sometime what happens, let's suppose we are having one scenario. This is my Palo Alto firewall. This is Ethernet 1/2 interface. This is Ethernet 1/3 interface. And this is your Ethernet 1/4 interface, right? And we are having DHCP server here. This is my DHCP server, and you are having few machines here and few machines here in behind this interval. So this is your inside, this is your DMZ, and you are having, this is like your server kind of zone, right? This is your server zone. Okay, now let's suppose on these machines, what you want, they can get the IP address from DHCP. So what they will do, they will just send the DHCP discover request, right? And these requests hit to your firewall. So now what it will do, by default firewall drop all these requests. Okay, but if you configure the DHCP relay on these interfaces, in that case what it will do, it will forward this particular request till your DHCP server, so they can get the IP address from DHCP. So this is the concept of your DHCP relay. Okay, now what is ECMP? So I will explain you ECMP by going into your lab diagram. So I'm having this lab. This is my Palo Alto firewall. Now I'm explaining your ECMP. ECMP stand for equal cost multipathing. So what happened? Let's suppose this is my primary ISP and this is my secondary ISP, and I'm getting the internet from these two. These are to my internet links, right? And this is my primary. So for now, all my data, it will go through this circuit. This is your primary circuit, right? If this circuit bend down, what happens? Your traffic will move towards your secondary path, which is the backup ISP. Guys, just give me 1 second. I'm getting one call from one of the student. So now let's suppose you are having 100 GB of link here. This is your 100 MB link, and this is your 50 MB link. Okay, and this is your primary, and this is your secondary. Now what you want? You want your 60% traffic. You want if 60% traffic will go through this interface, and I want my 40% traffic. It can go through this link. Okay. So now if you want this kind of setup, in that scenario, what happens basically, how you can achieve this thing? So if you want to achieve this thing, you have to configure ECMP, equal cost multipathing. So you can basically configure this thing in such a way. So like you will get 70% from here, 30% from here, or you can also go with the 50-50%, right? So these kind of thing, if you achieve, you have to configure equal cost multipathing. Generally, in production environment, we don't use ECMP. Okay, we if you are having a this kind of scenario, primary ISP, secondary ISP, we always use policy based forwarding. That's it. We never use this ECMP kind of things there, guys. Okay, but it is there. So let me just explain you. Okay, so now let me just show you the configuration of these things. Let me first log in into my firewall. If I run this command, shows interface management. So IP address of this management is 192.168.137.10. So I'll just log in by using this IP address 192.168.137.10. Let me open my Moga Xterm. Admin add 123. Let me log in on the firewall. Okay, so I'm just logging. It is taking some time. Okay. So now let me just show you how we can configure the DHCP settings first. So to configure DHCP is very easy. What I can do, you can go to into network tab and you will get this DHCP option, right? If you want to configure this firewall as a DHCP, so what you can do, you can just configure the DHCP. So on which interface you want to enable the DHCP? What I want to enable DHCP in Ethernet 1/4, but Ethernet 1/4 is my towards my DMG side, right? So I will just enable the DHCP into this interface mode. I'll just click on enable. What is the pool? So I want to use the pool is 10.2.2.0/24. Go to, you can also reserve the IP address by using the MAC address. So you can also configure the IP to MAC binding. And just enable ping IP when it is allocating. So when any new IP address is allocated, you can ping it. Right now lease is unlimited, means if he will assign one IP address or allocate IP address to machine, lease is unlimited. You can if you want, you can just configure the timeout. So for one day, this machine can use this IP address. Okay. In options, gateway, what is the gateway? So gateway IP address is 10.2.2.250. Subnet mask 255.255.255.0. Primary DNS 10.1.1.220. Secondary DNS 8.8.8.8. You can define another option: primary bin servers, primary NIS server, then NTP server, POP, SNMP, DNS, all these things you can define. Or you can also use the default option actually. So we are having around DHCP options starting from 1 till 255. So if you want, you can use these options as well. Okay. I'm not using, I will go with the basic thing only. And let's just click on OK. So now by doing this, I have configured this firewall as a DHCP server. I have this particular router here, DMZ. I'll go into this DMZ router. Enable conft do so IP interface brief. So right now what I will do, this is the interface which is connected towards this, right? So what I will just go inside this interface, F0/0, run this command, no IP address and IP address, and I want this IP address from DHCP. So I will just use a DHCP, shut down, then run no set on this interface. Now what it will do, now you will see on this interface, we will get the IP address from DHCP. So IP interface brief. Right now there's no IP address is not assigned. We will wait for some time and just go into your Palo Alto firewall, click on view allocation, or what happens, you have to basically do the commit because we have just configured it. After this commit, you will see when this machine, it will send the request for DHCP, that machine, it will get the IP address from DHCP. Let me start the capture on Ethernet 1/4, so you will get the things. Wireshark, I have started. Just wait for this commit to complete. It'll follow yes, MP log, DHCP client.log file. I have just enabled the logging on this one. Let me open one more session for the same. Now you will see after some time we will get the IP address from on this interface. See, I have got the IP address. It is basically coming from the Palo Alto 10.2.2.1. Show DHCP server lease interface. You can just use here all. This is the command which we can use, and you will see right now it has assigned one IP address. This is the IP address, this is the MAC address, host name of this router is DMZ router, right? So this is how basically your DHCP works in your Palo Alto firewall. Right now, Palo Alto is acting as a DHCP server. And you will see I have got the IP address from DHCP here, right? And you can see the allocation. So this is how we will configure the DHCP. Now, if you want to configure DHCP relay agent settings, you can able to do that from here. You have to define your interface. You can define the IP address of your DHCP server. So like that, we can basically configure. Let's suppose your DHCP server IP is 10.2.2. Let's suppose 100. This is the IP address of your DHCP server, right? What it will do if my firewall receives any request for DHCP, what it will forward these requests towards this server. Okay, so I think on this interface we are running this service. That's why I can just use this interface then, because on this interface itself we are running DHCP, right, service. That's why. So like that we can configure the DHCP relay settings. Now, if you want IP address on your Palo Alto interfaces, you can go to into this interface, Ethernet 1/5. Select the interface type is layer 3. Select virtual router. Let's say this interface is also in DMZ zone. So go to into IPv4. When you will select this option client, what will happen in that case? Your firewall get the IP address from any DHCP server, right? So like that, we will configure the DHCP client setting, guys. Okay. So this is how we will configure your DHCP. Okay. Now let me just explain you the ECMP, how it works. So I have basically put these knowledge based articles. You can use these articles. So let me go for, let me just open here. How to implement ECMP, load balancing on the firewall, right? So this is how we generally configure the ECMP. If you want, you can go through with this document. Okay, it will give you all the details, how we will configure and everything. Okay, this is the another document, so you can just refer with these articles. And if you will type here ECMP plus Palo Alto, you can open this particular document. Click on ECMP load balancing algorithm, so you will get the ECMP related algorithms here, right? These are the 4 algorithm: hash based algorithms, balanced algorithms, and weighted algorithms. Okay, on the basis of weight value. So let me just show you how we can configure it. So to configure this one, we have to go to into your network tab, then you can go into your virtual router, VR0. Let me just go inside this VR01. Static routing, or before going to static routing, go to into route setting, go into ECMP. Now what we will do, we will click on enable. So what it will just enable the ECMP. Symmetric return, stick source path, we don't need to select these options. Maximum path you can define, so minimum is 2 and maximum is 4, right? So you can, if you are having up to 4 connection till ECA till ISP, you can configure the ECMP, right? So I'm only having 2, so I'll just go with the maximum path is 2. And the first method which I want to test, which is balanced round robin. So in balanced round robin, what happens? My 50% traffic go through my primary ISP and 50% go through my secondary ISP. Means if I'll send the 100 packets from here, then 50 packets go from here, 50 packets go from the secondary one. Okay, like that your distribution will happen. So let me just first go with the balanced round robin. Let me just enable it. Let me go inside this one again. Now go to into static routes. Let me go into this ISP. Guys, I'm just disabling this path monitoring, so I can just give you the exact count of these packets. Okay. Otherwise, in production environment, you should use the path monitoring here. Okay. But I am just disabling, and just put the metric value 10 here. Go into the second route and put the metric value 10, because this time this is the case where you can have 2 default route with the same active AD value or same metric value. Click on OK. Now do the commit. Just wait for this commit to complete. Meanwhile, go here. Let me go inside this internet router. Enable debug IP ICMP. So I have basically just enabled the debugging. I'm still getting these ICMP ping from these ones because path monitoring is enabled, right? But we have just disabled. So after this, when this ping is succeeded, you will see we are not getting any packets. Wait for this thing to complete. Okay, configuration committed successfully. Okay, now I'll go here. Now what I will do, I'll go into this particular router R1 and I will just do the ping to any IP address on in this particular server, and you will see 50% packet you will see from primary and 50% from secondary. So how we can test that? Go to into inside R1, just do the ping to 8.8.8.8 and just send here around 20 packets. So you will see right now there is some intermittent drop is going on. Let me go inside this server. And so you will see all the packets are coming from this only 150, 1.7.250, right? There's no packets from 161 is dropping. So I have to check the configuration. Is there anything missing on the config? So let me first go into this forwarding information base. So both route right now in active state, right? Monitoring is disabled. Let me go into the policies. Policy based forwarding, I think PVF is configured. That's why it is happening. So I have to disable the PVF. PVF rule is there, right? So what I can do, let me disable the PVF. PVF has been disabled now. Let me go into the net. I'm having to pad tool, right? So now let me do the commit and we will just do the test. Generally, if you are having policy based forwarding, in that case, we don't use ECMP, guys. Just wait for this commit to complete. Meanwhile, I'll go here. So ECMP, so routing, press the question mark, path monitoring route, ECMP, yes, run the command. So this is the ECMP right now. This is the route which we have configured with the ECMP, right? There are few other commands. If you will go into this one, can you check this command, fib lookup default routing default ECMP, right? You will get the output. Let me see if I have another command. Okay, we are having only this command. So route fib virtual router default ECMP. So routing fib ECMP. So what it will do, it will tell you the forwarding information base. Right. This is the default route which is get using the ECMP, right? And you will see maximum fib entry. You will get all the details here. Commit has been succeeded. Let me go this time. We also go down, and what I will do, I'll just go here and just send the 20 packets again. Why it is dropping the packets every time? Because I can see I'm getting only the ping from this one 161. It is not going through. So let me go to into this ISP, check the status. So IP interface brief. Okay, see, this particular interface in down state right now. This was the reason, I hope. So F0/0, no shutdown, right, ma'am? Let me now again initiate some traffic, 20 packets. Some drops are there, right? After that, you will see continuous ping is going on. Let me go down. Let me again send these 20 packets and we will do the count. 20 packets I have sent from here. Go to into this and look for the packets now, guys. Your first packet from primary ISP, packet from secondary, then primary, then secondary, then primary, then secondary. Again from primary, this is from primary, this is from secondary, right? You will see 50-50% distribution right now. Okay, so if you will go with the balanced round robin, what it will do, it will go for the 50-50% distribution, right? So if you go into the network virtual router, go into your virtual router here, routes, route setting, ECMP. I am using balanced round robin, which means 50-50%. Now what I want, I have one requirement. I want my 70% data can go from primary ISP and my 3% data or 30% data or packets can go from the secondary ISP. Now I have this requirement. How we can do that? In that case, we have to go with the weighted round robin and we can define the weight values. What I want here, 70%, and in Ethernet 1/2, I want 30%. Means I want 3 packets from secondary if 10 packets are coming, and remaining 7 packets I want from primary. Go and do the commit here. If you want, in balanced algorithm, what happens? A balanced round robin algorithm distribute the incoming session equally across the links. Means it will do the 50-50% distribution, equal distribution. Now we are having another one is weighted algorithm. It is an extension to the ECMP protocol, and what it will do here, we can basically do the, or we can do the load balancing on the basis of weight value. You can just go through with this example as well, right? So like we are having Ethernet 1/1 enter with 100 Mbps, Ethernet 1/8 with 200 Mbps, right? And you will get all the details. So we can define this ratio as well, 2:1 means 2 then 1, and I have defined 70-30. So I can also go with 7 and 3. Like that also we can achieve. It's totally depends on us how we want to configure the things. Okay, let's wait for this commit to complete. And the other method, other algorithm is for hash based algorithms. So we are having two hash based algorithm, IP modulo and IP hash algorithms are used hash based information for the packet forwarding. What they will do, they will take the help of source IP address, destination IP address, and what they will just calculate the hash value, and according to this hash value they will basically do the forwarding. Okay, so now let me just test this thing. What I want this time, I'll just send only 10 packets for the same. All packets are succeeded. Go to into this one. Now you will see you will see 70% traffic from your primary and 30% from secondary. So this packet is from secondary, this packet is from secondary, and this packet is from secondary, which means your out of 10 packets, 7 Out of your 10 packets, 7 packet is going from primary, and remaining 3 packets, they have just take the secondary path, right? So this is your weighted round robin, where we have defined the weight values actually. Okay. Go into your virtual router again. You can also define like that. Go to into ECMP. What I want a ratio for 2:1, which means if 3 packets will come from my firewall, I want 2 packets can go from primary and 1 packet will go from the secondary. So you can define these kind of ratio as well. These are just a weight values, guys. And it will serve your task. What we will do now, we will send around 6 packets. Okay, and you will see 4 packets is handled by the primary ISP and 2 packets is handled by the secondary ISP. Now you will see this thing. So let's wait for this commit to complete and we will just do the test. Okay, so my commit is complete around 99%. It's 99%. Yeah, commit has been done. So now what we will do, I'll go into this one, same from inside, and what I will do this time, I will just send 6 messages. 6 ICMP ping I have sent. Go to into this one, debug is already there. You will see this is the 2:1, right? 1 packet. So this is your 1, 2, 3, and 4. 4 packets is going from your primary ISP1 and remaining 1, 2. These 2 packets are from secondary ISP, right? So that kind of basically configuration we can achieve by using this method, guys. Now, apart from this, what we have to do, if you go into this virtual router again, if you go into ECMP, the another method for ECMP is that we are having IP hash and weight values, right? IP hash. So what I can do, let me go into this weighted. Let me just delete this thing, weighted values. And this time what I want, you can use IP hash or IP modulo. In IP modulo, what happens? They will calculate the modulo. So what they will do, they will take your source IP address and they will just calculate the modulo value. Okay. And after that, what they will do, now if you want how to calculate the modulo, you can just go into Google and just type how to calculate modulo for IP address. How to convert IP address to the binary. So modulo means, or if you will type here plus Palo Alto, so you will get the Palo Alto thing. If there is any document, you can basically get that document there. Okay. So now what I want to tell you, you can just check these documents, active load sharing and all, because here also they will calculate the IP modulo value, right? So you will get some information here. But in modulo, what I can do, let me just give you some brief about that. In IP modulo, what they will do, they will convert your IP address into the binary form. Okay. And what if you will get the result 0? That time maybe it will go through your primary ISP. If you will get the result 1, then it will choose the secondary ISP, right? Like that, they will do the calculation. Like if you will, they will get the even values. That type will go from the primary. Odd value, that traffic goes from the secondary, like that. So if you are getting even value, which means result is 0. Okay, so like that way. If you will get the odd value, then result is 0, and even value, result is 1, right? So like that they will do the basically transfer of data. Okay, so now what I will do, so I'll go here and you will see I've configured these values. Now you can basically do the testing here. So if you will see this machine, I'm having IP address which is 10.1.3.101. Another IP address on this machine is 10.1.5.101. These are the IP address I'm having, right? You can just count the values. Just count 10 plus 1 plus 3 plus 101, right? What is the result for this one? The result for this one is 124. Count these values. So this is your even value, right? Just count this value, which is 10 plus 1 plus 5 plus 101. Or I think that result is 114 actually. Or 115. That's the result. Okay. I'm not good with math actually. So it's 105, not 105, it's 115. This is the addition of this particular IP address, right? Just what is the addition for these values? 7. We do have this value, so total is this one is 16 plus 101, so that value is 117, right? Apart from this, let's say what I want, I'm looking for some odd value. So on this one I'm having IP address 10 plus 1 plus 2 plus 101, right? So the value for this one is 114. This is the value on this one, right? So what I will initiate some traffic from this machine and some traffic from this machine, and we will see the difference. Okay, now what I can do, let me just start the ping from inside R1. Okay, ping 8.8.8.8. So you will see it is taking your primary path, right? Now go to into inside R2 and just do the ping 8.8.8.8. It has dropped one packet. Go here and you will see it is also taking the primary path, right? So what they will do, they generally do the calculation for source and destination, I hope so, right? Whatever value they will get, they will choose the ISP accordingly only. Okay, according to the parity value. If I'll go into this switch, let me just do the ping from this switch. Ping 8.8.8.8. Ping is working. Also it is just going through the primary one, right? So IP interface brief ping 8.8.8.8, press the question mark and define the source. But you can do in your source, you can use these IP address, right? Let me just use this one 10.4.100. Go here, you will see it is also going through the primary ISP only. 3.100. So it is going from the primary only. 2.100 primary. So it is taking the primary ISP for most of the packets, right? So that's why we don't use that particular method generally. Okay, now there is a one more method for this one is, if I'll go here in ECMP, the last method, which is IP hash. This IP hash generally we will use, guys, in production environment. And what I want, to use this source IP address to calculate the hash value. Now what they will do on the basis of source IP, they will calculate the hash value on the information in the packet, such as source and destination address, because the header of each flow in a given session contains the same source and destination information. These options prioritize session stickiness, right? So if you want a stickiness on your session, then we can choose this IP hash method. Stickiness means if we want the traffic for some source, it will always go from the primary ISP. In that case, we can basically go with this method, IP hash. Hash can be based on the source and destination address, or the hash can be based on the source address only. Using an IP hash based on only the source address causes all sessions belonging to the same IP address to always take the same path, right? So if you want this kind of setup, you can go with this particular method. So I will put this link as well, so you can just check this particular link. Let me, so this time we are using hash method, right? So what I can do, if this time I will do the test, I'll go here into this switch and I'll just first ping by using this IP, just taking the primary path, go into the switch, ping by using this IP, taking the secondary path for this one, just use fourth one, and you will see it is taking the primary path, and the other one we are having, which is 10.1.1.100. It is taking the secondary path, right? So you will see this time I have just changing this value, right? 1, then 4, then 3, then 2, right? So for like value when we are having 2 of 4, right? It is taking the primary path for values 10.1.1.100. So it is basically your even number, right? If you calculate all these 10 octet values, so it is even. If you calculate this value, it is also even, right? So means even packet it is sending from the secondary ISP. Okay, so like that we can basically do the load balancing. So in production we use this hash based method, right? And I have run the debugs, and all debug is also going on. So we have received that time this discovers and all, right? Offer it is given by the Palo Alto, right? So you can also verify all these packets by using the Wireshark captures. Let me close this Wireshark capture. Okay,